Okay, hello geometry students. Shall we try this again? Let's try it again. Flipgrid question of the day is still where it was. You have found the YouTube lesson, and this time it has sound. You should pause this video at this time and do this problem. You should try it, and then unpause it and do it with me. Okay, so, first things first, we want a different color. I am asked to find tangent of J and tangent of K. So first, let's take a look at J. So here's J. And if this is J, if this is the angle we're looking at, that makes this the opposite, and this the adjacent. Of course, the side opposite our right angle is always the hypotenuse. Remember, the key here is that tangent of theta is equal to opposite over adjacent. That's the key here. So if I am looking for tangent, and let's use a different color that's easier to see. If I'm looking for tangent of J, I'm going to do opposite 24 over adjacent, which is 32. And whoops, I am unprepared. Honey, could you bring my calculator? Technical difficulties, folks. So 24 divided by 32 is roughly, thank you so much. It is 3/4. Wow, he did that without a calculator. Good for him. Oh, I see how you did that. Okay, I see how he did it. 8 times 3 is 24, and 8 times 4 is 32. So you just divide the top and the bottom by 8, and you get 3/4. Okay, cool. Fun facts with Mr. and Mrs. Dodge. Okay, so 24 divided by 32 is 0.75, which is the same as 5, which is the same as 3/4. Beautiful. Okay, so now we are going to look at K, as we want to find the tangent of K. Again, we are going to look at the opposite over adjacent, but now the opposite and the adjacent are different because we've switched angles. So now my opposite is no longer, this is no longer my opposite. My opposite is now over here. This is my opposite, and what was my opposite has now become my adjacent. So, my opposite is always the side opposite the angle. So my opposite is 32, and my adjacent is 24. And you can see just how the numerator and the denominator flipped. That will always happen if you're looking at the same triangle, but the other angle. They'll always just switch like that. Okay, so 32 divided by 24 is approximately 1.3. 1.33. It's actually 1.33333, so if you wanted to put the little repeat bar over there, you could, but you don't have to. Yes. There you go. That is the entry task. Alrighty. Moving on to what we have for today. The learning target says, I know what sine and cosine are. And the success criteria says, I can use the sine and cosine ratios to find side lengths. So we're going to do the same thing we did on Friday, but with sine and cosine instead of tangent. So, first thing you need to do is put this in your notes. This is the definition of sine. So, pause the video, write that down, and then unpause so that we can chat about what it means. So sine is a trigonometric function or an acute angle theta of a right angle, denoted by sine is equal to opposite over hypotenuse. Just like tangent was opposite over adjacent, sine is opposite over hypotenuse. And so if we're looking at this theta here, you can see that 4 is my opposite, 3 is my adjacent, and my hypotenuse is always opposite the right angle. So that opposite just went right here, and that hypotenuse just went right here. Yeah. Pretty straightforward. If tangent made sense, this should make sense. Fantastic. Okay, so the next thing we're going to talk about is cosine. You should pause this and put this in your notes, and then unpause so we can discuss. Different color. So, cosine is also a trigonometric function for an angle in a right triangle, but cosine is adjacent over hypotenuse. So if we're looking at the same theta, the opposite, adjacent, and hypotenuse are all the same, but now we're looking at adjacent over hypotenuse. And now I know what you're thinking. Mrs. Dodge, this is too much to remember. Sine, cosine, tangent, adjacent, hypotenuse, what? I know you might be thinking that. But wait, there's a special way that we remember all of these things, and you heard it in the Get Triggy With It video that we watched on Friday. You heard it. It's called SOH-CAH-TOA. SOH-CAH-TOA. And what this means is, we'll go back to another color now. The so part of it means sine is opposite over hypotenuse. See that? See that? See the so and the S and the O and the H there? So that's where the so comes from. Where does the ka, the SOH-CAH-TOA part of it comes from? Well, I bet you guessed it. The ka comes from cosine being equal to adjacent over hypotenuse, and last but not least, the TOA part of it that hopefully you remember from Friday stands for tangent is opposite over adjacent. So this is where our SOH-CAH-TOA comes from. It is a nice, easy way to remember which one is sine, which one is cosine, and which one is tangent. So, fear not if you were worried about remembering everything. Just remember SOH-CAH-TOA. And rewatch the Get Triggy With It video if you needed to. Okay, those are our vocab words for today. Let's put them all together. Important info. You don't gotta write this down. We already wrote this down. We're just gonna go over it. What this says is that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, which is what we just learned. So, yay, yay, we learned it correctly. Other takeaways from this picture is that these abbreviations right here. Sine is abbreviated as sin, cosine is abbreviated as cos, hypotenuse is abbreviated as hype or HYP. I'm going to add a few more to this list. I would like to add opposite gets abbreviated as OPP, just like you heard in the Getting Triggy With It when they talked about the OPP and the ADJ. That's what they're talking about. So speaking of the ADJ, let's add adjacent to the list, the ADJ. And of course, we learned on Friday that tangent is abbreviated with TAN, tan. Yes, okay. Wonderful. Yeah. Let's move on. Our first example asks us to find sine of S, sine of R, cosine of S, and cosine of R. Write each answer as a fraction and as a decimal rounded to 2 places. 4 is a little excessive for me. You want to do 4? Go for it. All that changes is the precision to which you've written the number. But it does not really make a difference to me. Okay, so let's start with sine of s. If we start with s, that means that this is my opposite, this is my adjacent, and this is my hypotenuse. If I look at sine of s, we are looking at opposite over hypotenuse. So that is 63 over the hypotenuse, 65. So that's as a fraction. Now let's write it as a decimal. 63 divided by 65 is 0.97. Wonderful. There you go. There you go. That's sine of s. Since we've already got the whole thing labeled in red for angle s, let's just keep going with s, and we'll do cosine of s. Remember, cosine is the adjacent over the hypotenuse, and the adjacent is 16, and our hypotenuse is still 65. So this 16 divided by 65 is approximately 0.25. Beautiful. Alright, let's switch colors. And now we will take a look at r, sine of r and cosine of r. So remember that when you switch the angle you're looking at, you also switch the opposite and the adjacent that you're looking at. So now the adjacent becomes the opposite, and the opposite becomes the adjacent. So now when we're looking at sine of r, we are still looking at the opposite over hypotenuse. So this will be 16 over 65, which is approximately, wait a minute, oh my goodness, 16 over 65, that's right there. That's right there. Cosine of s was 16 over 65. Huh, interesting. So, I don't even need to put it in the calculator. I'll just steal the number from over here. So this is approximately 0.25. Okay. Ooh. Okay, and now let's take a look at cosine of r. Cosine of r, remember cosine is still adjacent over hypotenuse, SOH-CAH-TOA. So my adjacent is 63. And my hypotenuse is 65. And, oh my goodness. Oh my goodness, do you see that? 63 over 65? That's what sine of s was. What is going on here? Oh my goodness. So the sine of one angle is equal to the cosine of the other angle? What? Is this a thing? Is this always gonna happen, or is this just some crazy coincidence? I think you may have guessed. This is no coincidence. This will always happen. This is a thing. We're going to learn about it later, but for right now, I want to encourage you to think about why. Why is this happening? Think about it, and we will talk about it in a little bit. So we can just use the same numbers as we did for sine. Approximately 0.97. Fantastic. And we'll learn about why sine of s and cosine of r are the same thing in the third example for today. But our next example, let's check if we were right. Boom. Boom. Yes, we were. Fantastic. Okay. Finding leg lengths. Okay. Peachy. Same thing that we did with tangent, but now we're doing it with sine and cosine. So, let's go back to this color. I don't know. The values of x and y using sine and cosine. Round your answers to the nearest tenth. Ooh, tenth. Yay. And make sure you pay attention to what the instructions say about how to round and what to round to. Okay. if we're looking at this angle right here, if we're looking at angle 26, that means that this is the opposite, and this is the adjacent, and of course, as always, the side across from the right angle is my hypotenuse. Okay, so now if I want to find x, we're going to switch colors here. If I want to find x, I'm dealing with the opposite side here. So which of my SOH-CAH-TOA, which one has to do with the opposite? Well, let's see. Sine and tangent both deal with the opposite. Today, we're just dealing with sine and cosine, so you know that we're not going to use tangent. But also, well, there's another way we could figure it out, but if we used TOA, then opposite over adjacent, well, I still don't know what the adjacent side is. So tangent isn't going to help me. So you know we're using sine. So if I take sine of 26 degrees, that is equal to the opposite, x, over the hypotenuse, which is 14. Beautiful, beautiful. Now to solve this, to get x by itself, I just need to multiply by 14 on both sides. So, 14 times sine of 26 degrees is x. And we need to know what 14 times sine of 26 is. I realized today that not all of you have calculators at home. If you Google it, it'll tell you how to do it. Desmos also works, so I'm gonna upload a YouTube video later today, tomorrow, about how to use the online calculators if you don't have one with you. But for now, use what you have. Hopefully you figured something out. 14 times sine of 26. Make sure that your calculator, whichever one you are using, is in degrees and not radians. It should say deg or deg instead of rad or rad. Radians are something different that we can talk about if you want to, but you won't learn that until next year in advanced algebra trig, probably. Okay, so 14 times the sine of 26 is approximately 6.1. Approximately. That's what the squiggly equal sign means, is approximately. And there you have it. Fantastic. Okay, now let's take a look at y. We'll use a different color. So if I want to look at y over here, that is the adjacent side. Well, hey, which one of these up here in my SOH-CAH-TOA deals with adjacent? Well, let's see here. I have cosine and I have tangent. And you could use either one. Now that we know what the opposite side is, we could use tangent. But because the opposite side is still like a decimal, it's still an approximation. If we use an approximation to do a problem, then that problem is just going to be another approximation. So when you can, don't use the approximate numbers. So don't use tangent. When you can, use the nice whole numbers you have, like you do here in the hypotenuse. So let's use cosine. All of that was just to say that we should use cosine. Cosine of 26 degrees is equal to adjacent. Cosine is adjacent over hypotenuse. That's what the CAH in SOH-CAH-TOA tells us. So the adjacent is y, and my hypotenuse is 14. Okay, different color here. To get rid of the 14 on the bottom and get y by itself, we are going to multiply both sides by 14. Get that out of there. And now we have 14 times cosine of 26 is equal to y. Same thing, shove that bad boy in your calculator. And we get that 12.12 0.6 approximately is equal to y. Fantastic. Okay, perfect. Yeah, so pay attention to which angle they give you in the beginning. Here we had that, we only had the 26. But pay attention, because that angle, this angle, determines what's your opposite, what is your adjacent. Remember, your hypotenuse stays the same no matter what. But then also pay attention to what side lengths they give you. So here they gave us the 14, and they didn't give us anything else. What side lengths they give you determines which of the SOH-CAH-TOA you can use. So if I have the adjacent and the hypotenuse, I'm using cosine. If I have the opposite and the adjacent, I'm using tangent. So pay very close attention to which angle you have and which sides you have. Okay? Alrighty. Oh, let's check and see if we were right. 6.1 and 12.6. Booyah. Booyah, we were right. Okay. So this is technically extra. You won't need this for your homework, but we will have bonus questions. So this right here is why in that first example we had cosine of s equals sine of r. This is why. And what this says, sine and cosine of complementary angles. What were complementary angles again? Were those the angles that told you your hair looked nice? No. No, they are not. This is complementary with an E. And what complementary angles are two angles. So let's for example, say angle A and angle B. If these are complementary angles, that means that the measure of angle A plus the measure of angle B equals 90 degrees. So complementary angles are two angles that add up to 90 degrees. So if I have A and B that are complementary angles, then the sine of A is equal to the cosine of 90 degrees minus A, which gives us the cosine of B. And the reason for this is because, let me draw, I want it bigger than that. Let me draw you a right triangle here. And what's special about this triangle is these two angles in this triangle, let's call them A and B, they will always add up to 90 degrees. Because there's 180 degrees total in every triangle, and this is 90 degrees, and 180 minus 90 is 90. So these two angles, these two right here, together always have to be 90 degrees. That happens in any right triangle. So, sine of A equal to cosine of B. Cosine of A equal to the sine of B. And it's because of this. It's because 90 degrees minus A equals B. There's another fun way. Next year you will learn another fun way to see this in action when you graph sine and cosine. Unfortunately, we won't do that this year. That's Advanced Algebra Trig. If you wanted to see that, I'd be happy to show it to you. Maybe on the YouTube live stream every day from 12 to 2 p.m. Every weekday from 12 to 2 p.m. But yes. So, sine of B equals cosine of A because 90 degrees minus B gives you A. All right. Let's see an example of this in action, shall we? And again, this is an extra example and not required for homework. This is purely for fun. Write sine of 56 degrees in terms of cosine. Okay. All right. So sine of 56. Well, remember from the last slide that sine of 56 degrees is equal to cosine of 90 degrees minus 56 degrees. Which, what is 90 minus 56? 34. So this is cosine of 34 degrees. And now we are in terms of cosine. There you go. So because it was as if this was our angle A, and then this was our angle B, because remember that sine of A is equal to cosine of 90 degrees minus A, which is equal to sine of B. Oops, that's cosine. It says cosine over there. Yes, so if ever you want to switch from sine to cosine, all you have to do is that 90 minus A there. And I know what you're thinking. Mrs. Dodge, why? Why would I ever want to do this? And the answer is that it will help you later. When you learn about trigonometric identities. It's a fancy way of saying stuff like this. When you learn about those next year, this will help you. And what if you don't have, like we're talking about sine, but I don't have the opposite. I only have the hypotenuse and the adjacent. I don't have the opposite side. Well, just turn it into cosine. And if you don't like cosine, just turn it into sine. And bada bing, bada boom. Yes. So that is where this might be helpful. Okay. Yeah, if you have questions, which, oh, well, yes, okay, we were right. Okay, and hey, if you have questions, Mrs. Dodge is still streaming on YouTube every weekday, Monday through Friday, from 12 to 2 p.m. It's a good time, so hop on over if you want to ask questions about math, or if you're just bored and wondering what Mrs. Dodge is doing. I'm going to start doodling, practicing my Spanish, playing the piano. I don't know. I'm going to start doing stuff on stream, and if you want to interrupt me to ask questions, please do. I will completely stop what I'm doing to answer your questions. But also, it can just be a place to chill if you want to. It'll be a place to, I don't know, we'll watch a cool YouTube video together or something, or we'll play the piano together or something like that. So feel free to check out that live stream if you want to. Alrighty. This is what your homework will be. You can do it now if you want, but you don't have to, of course. The first 6 questions ask you to find sine and cosine of D and sine and cosine of E. And the next 6 questions ask you to find the 2 variables, so x and y, p and q, w and v, whatever it asks you. And that's like the second example that we did. You do have bonus homework questions available, which are just like the last example we did. Write sine in terms of cosine, write cosine in terms of sine, 90 minus your original angle. And then, last thing I have for you today is your launch. Your launch today says, life is 10% what happens to you, and 90% how you react to it. And that is Charles R. Swindoll. So, I've had some crappy things happen to me in my life, and I'm sure you have too. However, no matter how many crappy things happen to you, it doesn't mean you can't have a good life. It might make it harder to have a good life, but it's never impossible to have a good life. So here's my mantra that I live by. If you can control it, change it. If you can't control it, you can't change it, change your attitude. So an example of that would be something that you can control. Say you get an F on a math test. Oh, darn it. Well, hey, you can control that. You can control how much you study. You can control whether or not you retake the math test. So, if you don't like it, change it. You can control it. Change it. Retake that test. Study super hard. Ask Mrs. Dodge questions. Check out all the solutions posted online. Do everything that you can to change the grade that you got, because you are in control of the grade that you get. An example of something that you can't change is, for example, you getting sick. Maybe you get a cold or something. You can't control that. I mean, you can go to the doctor and you can take medicine and you can drink lots of water and do that stuff. But you can't control how fast you recover or whether or not you get better. You can't snap your fingers and make yourself better. So change your attitude about it. Instead of being super grumpy, I'm sick, I can't do X, Y, or Z, my nose is stuffy. Change your attitude about it, and take it as an opportunity to relax. You know, I'm sick, so I can't run around and do everything I normally do, so I need to relax and let myself get better. So change your attitude from, I don't like being sick, to, I get to rest. Another example of something you can't change is, say, a boyfriend or girlfriend dumps you or something like that. You could try to control that, and you could run to them on your knees and say, take me back, wait, I'm sorry, you know, whatever you might say to them. But ultimately, you can't control whether or not they say yes or no. You can't control whether they love you or they don't. So instead, change your attitude about it. Instead of, oh, they broke up with me, no one will ever love me, I'm so alone. Like, no. Instead of thinking about that, change your attitude towards it. You know, that sucks. I really liked that person. I really liked spending time with them. They didn't feel the same way. But you know what? I know that I am still worthy and I'm still valuable. And just because they didn't think I was amazing, doesn't mean that I'm not amazing. So I hope they have a good life, and me, I'm gonna live my best life too, and one day I will find somebody that thinks I'm just as fabulous as I am. So yeah, doesn't mean that you can't still be heartbroken, doesn't mean that you can't still be upset, but you change your attitude about it. Instead of, this is the end of the world, you think like, oh, this sucks right now and my heart really hurts, but eventually I will find someone new, it will get better. Yes. So, if you can control it, change it. And if you can't control it, you can't change it, change your attitude. That has helped me through many, many things in my life, and I hope that it does the same for you. So yes, that's the launch. That is all that I have for you today. I hope you enjoyed it. The second time round, with audio this time. Yes, if you have questions, tune into the live stream, email me, all those fun things. And yeah, we'll see you tomorrow in the next video. Bye!